Hello, in this video we're going to be using our trig functions sine and cosine to model the behavior of a wheel that is rolling across a straight line path. So we have a wheel here with 1 foot radius. Point P is sitting on the ground and as the wheel begins to move 20 feet per second, point P will start to move around the circle with the wheel. So we want to draw a model to represent point P's distance as it travels around the wheel. So as it comes this way after t seconds, and then we're going to use that information to find an equation for this. So the things that we know, first of all, we can determine the circumference of this circle, or that is, how long or how far is P traveling if it goes around the circle one time. So the circumference formula is 2 times pi times the radius, and the radius is 1, so 2 times pi times 1, or just 2 pi. And so that is in feet, and so that is my radius. So if we wanted to find the period of this function, it's going to be in the number of feet I've traveled, so that would be 2 pi feet, divided by the rate, so that would be 20 feet per second. And so if I do 2 pi divided by 20, the feet will cancel, and I'll be left with pi over 10, and seconds, we're dividing by a division of seconds, so that results in seconds. So every pi over 10 seconds, this P, point P, will be returning to the ground. Now let's talk about the height of P. At its maximum height, P has a value of, well, right here is 1 unit, and here is 1 unit, so the diameter all the way across is 2. So its max height is 2 feet, okay? And so its minimum height is when it's actually touching the ground at 0 feet. So let's go ahead and draw a rough sketch of this based on what we know. So there will be the y-axis, and there's my x-axis. Now point P, which I'll do in blue here because it's in blue, starts at 0 feet off the ground at 0 seconds. At pi over 10, it's done a full rotation. So that means that it's gotten all the way up to 2 feet and then is returned back to 0 feet in that time. And so at pi over 10, it'll be back at 0 feet. Exactly between those is half of pi over 10, which would put it at pi over 20. And right there at the halfway rotation spot is when it's going to reach its maximum height. So exactly between those is when it's going to reach its average value of 1. And so we come up and down. Okay, and then we can just repeatedly follow along with this. So here's going to be pi over 10 times 2, which would be pi over 5. And so again, halfway between it'll peak and then return at pi over 5. And it's just going to follow this pattern the whole way here. So which trig function is it that models this behavior? Now sine would start at 0, 0 and would travel like that. We should stop there. That's 1 full period. So that's sine. Cosine starts at off of the midline and then comes down before going back. And so what I think we have here is, because our midline is right there, we're not starting on the midline, so I think we have cosine. Now sine and cosine are very close to each other in what they look like. Sine is simply a shift of cosine, or cosine is simply a shift of sine. So if you pick sine, that's fine, but you would have to shift it. As it is, cosine normally starts above the midline, but we're starting below, so we're actually going to have to do a negative value for cosine instead. Now, my amplitude, since I'm only up 1 unit and down 1 unit, my amplitude is simply 1. So when we write this equation here, I have y equals, and it'll be a negative 1 times cosine. We have to figure out what our period would be, and so normally our period is found by doing 2 pi over b. Well, we know what our period is. We know it's pi over 10. And so what value of b would make this true? And if we made b equal to 20, then your 2 pi over 20 would be the same as pi over 10. So my b is 20 here. And so to continue to write this, we have 20 times x, and then our midline has shifted up 1. And so this right here is the equation for p as it rolls forward at 20 feet per second, so the center is rolling forward at 20 feet per second. And so if you give me an x value, then that's going to be the amount of time that p has been rolling forward, and the output would be where p is positioned on this wheel, somewhere between 0 and 2. Okay, for now we are done.